And now let's look at formula and substitution. A formula is an equation with letters which stand for quantities. Let me take it again. A formula is an equation with letters which stand for quantities. So for example, C is equal to 2 pi r is the formula which gives a circumference C of a circle of radius r. So this means that the formula for the circumference of a circle is 2 pi r. This formula gives the value of the circumference, so pi and radius are related. So this relationship gives us, by the time we put in the values of pi and r, we'll be able to get the value of c, which is the circumference of the circle. And the circumference of the circle means the distance or perimeter around a circle. In science, I, which is current, is equal to V over R, where V is the voltage and R is the resistance. So this is the formula for current in science, and this is especially physics. So I equals to V over R is the formula which shows the relation between the current I amps, voltage V volts, and resistance R ohms in an electrical circuit. In arithmetic, I is equal to PRT over 100, and this is a formula for interest. So I equals PRT, P times R times T over 100 is the formula which gives the interest I gained on the principal P invested at R% per annum for 2 years. Sometimes the same letter can stand for different quantities in different formula. For example, I stands for current in science formula, this formula here. I stands for current in science formula, and I stands for interest in the arithmetic formula, which is this formula here. Yeah, formula is the plural of formula, so this is the plural of this. Now let's talk about substitution. What is substitution? Substitution, to substitute in a formula means to replace letters by their values. This makes it possible to calculate other values. So if most times substitution comes in this form like this, say that if A is equal to 2, B is equal to 3, C is equal to minus 4, find 2A minus B raised to power 3 over 4C. So what it implies is that simply substitute or replace these letters by the values of the letters here, or the values given to assigned to each letter. So let's add A, put the value that A is equal to. A is equal to 2 minus B is equal to 3, so 2 raised to power 3 over 4 times, this bracket means times, so C is equal to minus 4, so put minus 4 in place of C, minus 4. So 2 raised to 2 times 2 is 4, minus 2 raised to power 3 is 3, I mean 3 raised to power 3 is 3, times 3 times 3, and 2 times 2 is 9, 9 times 2 is 27, over 4 minus 4 is minus 16. So 4 minus 27, it gives us minus 23 over 16, minus 16. Minus we cancel out minus, give us 23 over 16. And this will give us 4 whole number 3 over so since okay, so yes, 1 whole number 7 over 16, a fraction. So that's all substitution means. It's simply to replace letters by their values. To replace the letter by the value, replace this letter by its value. Don't replace A by 3. A should be replaced by what A is equal to. B should be replaced by what B is equal to. C should be replaced by what C is equal to. So this is all there is about substitution. Then formula is simply an equation with letters, and these letters stand for quantities. So in this case, pi stands for a quantity, r stands for a quantity, r is the radius, I is equal to v over r. So v stands for voltage, r stands for resistance. In this case, p stands for the principal, r stands for rate, and t stands for the time. That's now a gas at a temperature of theta degrees Celsius has an absolute temperature of T Kelvin, where T is equal to theta plus 273. So it is find the absolute temperature of a gas at a temperature of 68 degrees Celsius. This is if the absolute temperature of a gas is 380 Kelvin, find its temperature in degrees Celsius. So we're given a formula to work with. The solution. Our formula is T equals theta plus 273. T is the temperature in Kelvin, which is also known as the absolute temperature, and theta is the temperature in degrees Celsius. Kelvin and Celsius are units of temperature, different units of temperature. We have up to 3 or more. We have the Fahrenheit, we have the Kelvin, and we have the Celsius. So we convert from this to this, or from this to this, and either from Fahrenheit to Kelvin and Kelvin to Celsius. So this particular formula connects Celsius to Kelvin and Kelvin to Celsius. So the question says a gas at a temperature of theta degrees Celsius has an absolute temperature of T Kelvin, where T is equal to theta plus 273. Find the absolute temperature, which is T in Kelvin, of a gas at a temperature of 68 degrees Celsius. So in this equation, we discover that our theta is where theta is number that is A, where theta, the value of theta is given as 68 degrees Celsius. So we put 68 degrees Celsius in place of theta in the equation, then we can get the absolute temperature. That's what substitution means. So T is equals to theta is 68 degrees, 68 plus 273. So we're going to add them together. 273, 68 plus 3 plus 8 is 11. 12 plus 6 is 13 plus 1, 14. 2, 41. This will give us 41 Kelvin. When writing Kelvin, you don't put your not on top. It's only Celsius and Fahrenheit that you do that. So Kelvin, there's no not on top, so it's 341 Kelvin. That's A. Then B. This is if the absolute temperature of a gas is 380 Kelvin, find its temperature in degrees Celsius. So come back, we write our formula again. T is equals to theta plus 273. Okay, so now the question says that the absolute temperature of a gas is 380 Kelvin, which means T is 380 Kelvin. Now we're going to look for its temperature in degrees Celsius, and that is theta from the same form, using the same formula. So we say where T rather is equals to 308 Kelvin. So since T is equal to theta plus 308 Kelvin, so we put T 308 in place of T in this equation. So 308 is equal to theta plus 273. Now the next thing is for us to be able to get the value of theta, we're going to collect like terms. These two terms are alike. So a rule that you must observe when collecting like terms is that this sign is for 273 is attached to 273. So since you're going to collect like terms, it means that 273 will have to move to meet 308 on this side of the equation. So when it crosses this equals to sign, it's going to, the sign will change from positive to negative. If the sign here was negative, by the time it crosses, it will change to positive, but now it's negative. So when it crosses, it's going to change to negative. So 308 minus 273 is equal to theta you can rewrite it and so theta is equals to 308 minus 273 and theta is equals to 308,273. 8 minus 3 is 5, and 0 minus 7 cannot remove from the 10 minus 7 is 3. 2 minus 1 is 0, so that's 35 degrees Celsius. So for Celsius, we put the knot on top. For Kelvin, you don't put the knot. The formula W is equal to VI gives the power watts. Power is in watts that an electrical appliance uses when a current I amps flows in a circuit of V volts. E says an air conditioner of maximum power needs a current of 25 amps in a 120 volt circuit. Find the power being used. So let's write our formula first. Our formula is W is equals to VI. So now, from what we're given in the sentence in part A, the question number 2 define each of the letters. W is power and the unit is watts. I is the current, the unit is amps, and V is the volt, the unit is the voltage, the unit is the volt. Okay, so now where I is equals to 25 amps, and V is equals to 120 volts. So we put this, remember we're doing substitution, so we substitute these values into the equation by replacing the letters with the values. So W is equals to, where we have V, we put the value of V here, 120. VI is multiplication, so we multiply. I here is equals to 25. This is equals to 120 times 25. 120, 25, 0, 10, 5 times 1, 5 plus 1, 6, 2 times 0, 0, 4, 2, 0, 0, is also 10, 3,000 watts power used. So that's 2. Okay, we call E. So the B part says an electric light bulb is sold as 100 watts, 240 volts. To find the current required to light the bulb. So if we write our formula, okay, VI. So we discovered that this time around the watt is known because the electric bulb is rated 100 watts, 240 volts. So this is for V volts and this is for W watts. So we're going to say where the quantities that are given to us is W, which is the power and the voltage. So W is equal to 100 watts. 100 watts. Where W is 100 watts and V was 240 volts. So say from the formula, 100 is equals to 240 times I. So we have to divide both sides by 240. So let's divide both sides by 240. So 100, so let's 240 times I over 240 is equal to 100 over 240. 0 cancel 240 cancel 240 1. 0 cancel 0. So I is equals to 10 over 24. 10 divided by 24. We come here and say 24 divided by 10. 24 into 10 can 0 point to add 0. 24 into 100. That's, let's see, 24 times 4. 4 times 4 is 16. 4 times 2, 8 plus 1, 96. 4 times 4 into 20. 4 times 96. 4 times 24 is 96. And subtract, you have 10 minus 6 is 4. And then here is 9, that is 0. 24 into 4 cannot add 0. 24 into 40 will give you 1. 1 times 24 is 24. Subtract. 10 minus 4 is 6. 3 minus 2 is 1. 24 into 16 cannot 160. 24 into 160. Let's try 24 times 6 and see what will give us. 4 times 6 is 24. 2. 6 times 2, 8 plus 2. 6 times 2, 12 plus 2, 14. 144. So 6 times 6 times 24, 144. We subtract. 10 minus 4 is 6. 5 minus 4 is 16. 24 into 16 minus add 0. 24 into 160 is 6 again. That's 6 times 24 is 144. So when you subtract, it will go on and on. So we call this a recurring decimal. So we're going to stop here. Final answer is 0.4166 amps. So if you want to approximate to the nearest, this is the first decimal, second decimal, to the third decimal. So let's say I want to approximate to the nearest 2 decimal place. I will say final answer is 0.42 amps to 2 decimal place. That's the answer. Solution. A circuit of voltage V volts and resistance R ohms has a current of I amps, where I is equal to V over R. Find the current when the voltage is 240 volts and the resistance is 80 ohms. So let's write our formula. I is equal to V over R. So where V, so we have 40 volts and R is equal to 80 ohms. So if you substitute I is equal to V, so 40 R is 80. Cancel 0, 80 and 1, 82. I is equal to 2 and B is the B says find the voltage when the current is 0.6 amps and the resistance is 50 amps. So we're going to look for the current. I is equal to V over R. So where I is equal to 0.6 amps and resistance R is equal to 50 ohms. So I is equal to V over R. I is equal to 0.6. 0.6 equals to V. R is 50. So this is over 1. Remember 0.6 equals to 0.6 over 1. So we'll put this in place of this. So since this part is fraction, this part we make it to be a fraction, then we cross multiply. So we say cross multiply, or if you don't cross multiply, you can leave it, remove the fraction and then multiply both sides by 50 and it's solved. Cross multiply 0.6 times 50. 0.6 times 50 equals to 1 times V. V times 1. V times 1 is V. So V is 0.6 times 50. V is equals to 30 volts. Well, for the mass of water in a rectangular tank 1 meters long, the mass of water in a rectangular tank L meters long, B meters wide, and H meters deep is m kilograms, where m is equals to where m is equals to 1000 lbh as length times breadth times height. What is the mass of water in a tank 5 meters long, 4 meters wide, and 2 meters deep? So we're going to start off by writing the formula. M is equals to 1000 lbh. L is length, breadth, and length, width, and height. So what's the mass of water in a tank 5 meters long, 4 meters wide, and 2 meters deep? So where L is equals to 5 meters, B is equals to 4 meters, and what H is equals to 0 meters. So we put these values in place of the liters in this equation. So M is equals to 1000 times 5 times B 4 times 3. That's equals to 60,000 kilograms. That's A. B. He says, how deep is the water in a tank 4 meters long and 2 meters wide if its mass is 24,000 kilograms? So our formula is M is equals to 1000 lbh, where first of all our mass is 24,000 kilograms, and the length is L is 4 meters, and the breadth, which is the width, is 3 meters. So if we put these values in place of the liters, N here is 24,000 equals to 1000 times the length is 4 times the breadth, the width is 3, and each is what we are going to look for. So 24,000 is equals to 12,000 each. So divide both sides by each by 12,000. So each, you can write 12,000 each over 12,000 is equals to 24,000 over 12,000. This will cancel this. So each is equals to 0.0000. 24 over 12. So here 1, 12, here 2. So each is equals to 2 meters. C. How wide is the tank? 3 meters long and 0.5 meters deep if it holds exactly 1 ton of water. So our formula again, M is equals to 1000 lbh, where M, we told that if it holds the rectangular tank holds 1 ton of water, that is the mass of the water is 1 ton, and where M is equals to 1 ton. 1 ton is equivalent to 1000 kilograms, and that's okay. Then what else is given to us? Okay, length 3 meters, length is 3 meters, and depth as each equals to 0.5 meters. 0.5 meters. So let's look for. So these are the values given to us for the liters. So we are going to look for B, which is the width. So we put this in place of this formula. Our N is 1000 kilograms. 1000 is equals to 1000 times length is 3 times height, that is breadth, the width times 0.5. Is 1000. So 1000 times 3 is 3000. 3000 times 0.5. 1500. 1500 times B. That's B. This is divide both sides by 1500. This will give us 1000 over 1500 equals to 1500 over 1500. 1000 over 1500 equals to 1500 1500. This will cancel this. This value is going to be 1 and 0 0 0 0. So B is equal to 10 over 15. 5 here is 2. 5 here 3. This is equal to 2 over 3. So therefore B is equal to 2 over 3. 2 over 2 meters, or if we divide 3 to 2 into 2 is 0. 3 to 26, this times 3, 18, and 2 into 2 corner 0. 3 to 26, 6 times 3, 18, 2, 0, 6. So when you have 0.666, 0.666 what? So if you approximate, when you have 0.67 meters to 2 decimal place. So that's the value for B.